Alrighty, so today we're going to be going over our module on quadratic functions. We're going to do a quick review of what we've covered in this particular unit. In this unit, we cover three major ideas. One, we cover simplifying algebraic expressions that involve combining like terms, distributive property, and multiplying polynomials. We then talked about distinguishing between linear, exponential, and quadratic functions. And the third major topic we covered in this unit was function notation, how to use it. So let's go through this study guide together so that we have something to review before we take that test. Simplify. In this problem, we need to simplify it. And the way we simplify this one is by combining like terms. There is no multiplication. There is no division. So we go straight to adding. So we got 2x's here, 3x's here, 5x's here. That's a grand total of 10x's. So we have 10x. Next, we have the constants, the numbers that do not have variables attached to them. We combine those, -2 and 3. We put those together, we get a +1. And that's how we simplify this particular problem. We have 10x plus 1. We gathered our x's, put them together. We gathered our 1's, we put them together. Boom. That's all it is to this one. Let's go on to the next. X squared minus 3x plus 1 minus 2x minus 4x squared. Now we have this negative sign in this second set of parentheses. We need to take that negative and we need to distribute it. We need to pass it on out. So let's do that. X squared comes down, minus 3x plus 1 all comes down. Now we need to take this negative and we distribute it. Minus 2x, a negative and a negative, make this plus 4x squared. Now, CLT, combine those like terms. So we got 1x squared here, we got 4x squares there. That's 5x squared. Then let's see about our x's. We got negative 3x here, negative 2x here, so that's negative 5x. Then for constants, we just got that 1 plus 1. And that's how we simplify that one when we have to distribute before we combine like terms. We distribute, then we combine the like terms. That's how we do that problem. Simplify the quantity of x minus 7 squared. First thing we need to realize about this is when we have that exponent of 2, that means what's in parentheses is used as a factor 2 times. So we can therefore rewrite this. It's perfectly fine to rewrite this as x minus 7 times x minus 7. Okay, we have that. Now we have a few different ways of doing this. We could double distribute this, or we could use the box method. We also have the algebra tiles method. There are multiple ways of multiplying this, but there is only one correct solution. There are multiple ways of getting to the solution, but there is only one correct solution in this case. And so we then multiply these out. And so the way we can do this, I'll show you the box method. X minus 7 times x minus 7. X times x is x squared. Negative 7x. When we do x times negative 7, same thing here. And then negative 7 times negative 7 is positive 49. We combine like terms and we could rewrite it. X squared minus 14x plus 49. That's how we take x minus 7 quantity squared. We then expand it multiply, then combine like terms. That's how we simplify that, by eliminating that multiplication and then making it into a trinomial. The quantity of 2y plus 5 times the quantity of 2y minus 5. Let's look at this one with the double distribution method so you can see that it's the same. You're multiplying it in the same way. First, we need to take this 2y and multiply by everything in the second set of parentheses. 2y times 2y is 4y squared. 2y times negative 5 is negative 10y. Now we need to also take that 5 and multiply it by everything in the second set of parentheses. 5 times 2y, that's 10y. 5 times negative 5, that's negative 25. Now we just combine like terms, and then we'll be done. Negative 10y and 10y like terms, they actually cancel each other out. So we have 4y squared minus 25. Boom. That's all it is to it. You take the two binomials, you multiply, make sure everything in the first is multiplied by everything in the second. Then you combine like terms. That's how you simplify. Sometimes we need to multiply twice. We take this 5, we multiply by everything in this set of parentheses, and we get 15x plus 10. Bring down the other one. Now we can just multiply these together to get our solution. That's all we got to do is multiply these together. (15x plus 10), 2x minus 7. Then we just multiply and combine like terms. So 2x times 15x, that's going to be 30x squared. 2x times 10, that's going to be 20x. (15x times negative 7, that's going to be negative 105x. And negative 7 times 10, that's going to be negative 70. We, of course, combine like terms. We'll end with 30x squared minus 85x minus 70. So in this one, once again, we took that number 5, we distributed it out. We then multiplied the two binomials like we did on the previous ones. So that's simplifying algebraic expressions. We did one where we had to take the number, multiply it on through. We did two binomials multiplied together where the middle terms happen to cancel out. We did one where we had a squared term and then we expanded it, then multiplied it. And we also talked about distributing a negative and also combining like terms. That's simplified algebraic expressions. The second big idea that we talked about was differentiating between linear, exponential, and quadratic. So let's jump into that. Classify the given function. So we have our x's here, and we have our y's. The x's are going up by 1. Now I have to ask myself, how are my y's changing? Remember, linear, you're constantly adding or subtracting the same term. Exponential, you're constantly multiplying by the same constant ratio. And then in a quadratic table, it's a constant second difference. And so classify this function. We're going from negative 5 to negative 4, that's up 1. Negative 4 to negative 1, that's up 3. Negative 1 to 4, that's up by 5. And from 4 to 11, that's going up by 7. So we see here we're not going up by the same number each time. We're not going up by any multiplicative pattern. Let's take a look at the second difference, because if the second difference is constant, then we have a quadratic. Second difference, that means we wrote out how these numbers in the y's are changing. That was the first difference. How those numbers are changing is known as the second difference. 1 to 3, that's up 2. 3 to 5, that's up 2. 5 to 7, that's an increase of 2 as well. So we will call this a quadratic function. A quadratic function. And that's all we would need to say for that type of problem when we see it on that particular assessment. If they ask us just to classify it, that's all we have to do. Say it's a quadratic because it has a constant second difference. Constant second difference. All right, we got ourselves another table here. Let's see how this one's changing. From 2 to 5, that's an increase of 3. 5 to 8, that's an increase of 3. 8 to 11, that's an increase of 3. 11 to 14, that's an increase of 3. We're constantly going up by 3, a constant rate of change. So this is linear because it has a constant rate of change. Now let's see how this one's changing. 2 to 8 to 32 to 128 to 512. Now, we can see it's going up by a larger and larger and larger amount. So let's see if multiplication works. 2 times what gives us 8? 2 times 4, of course, gives us 8. So that's times 4. Let's see, does that continue? 8 times 4 is indeed 32. And 32 times 4 is indeed 128. And 128 times 4 is indeed 512. So we have what's called a constant ratio here. We're constantly multiplying by 4. So we call this type exponential because it has a constant ratio. So that's the second major topic we dealt with in this module, is differentiating between linear, exponential, and quadratic. Now remember, this right here at this point is nothing new. This is all review. It's nothing new. This is review. We're taking those old ideas, we're bringing them back up, we're wrapping it together so we're nice and prepared as we're reviewing this particular module. The last thing we talked about in this module has been function notation. So function notation requires us to evaluate functions. They tell us, in this case, they're telling us the input and we have to find the output. So they're saying that this function, f of x equals x plus 3, if we input a negative 2 into this function, what is the output? So I need to take x out and put negative 2 in everywhere where I see it. So f of negative 2 equals negative 2 plus 3. So f of negative 2 equals negative 2 plus 3. That's going to be a positive 1. And that's our solution. The negative 2 goes in, 1 comes out. Let's try another one. If f of x equals x minus 5, what is the value of x when f of x equals 15? In this one, we're doing something different. We now have the output, which is 15. We need to find out what is the input that makes that so. So we need to work backwards and solve. So in place of the output, we put 15. So 15 equals x minus 5. Now we simply need to get x by itself. We need to isolate the x. We do that by balancing our equation. 15 is x minus 5. We need to simply add 5 to both sides of the equal sign, because in math we believe in balance. Because the inverse of subtraction is addition. So 20 equals x. 20 equals x. We also deal with interpreting. What do these words mean? What does function notation mean in a particular real world applicable context? Given that P of T represents the number of points scored by Michael Jordan in T minutes into a basketball game, what is the meaning of P of 20? So P of T represents the number of points scored by Michael Jordan T minutes into the basketball game. So here we have P of 20. 20 is where the T was. So thus that means minutes. So this will be the number of points scored by Michael Jordan 20 minutes into the game. That's all it is. It's the number of points scored 20 minutes into the game. That's all it is to this type of situation. Let's take a look at another one. F of x represents the number of pizzas needed to feed x people. What is the meaning of f of x equals 20? 20 is the output. F of x represents the number of pizzas needed. So we will say 20 pizzas will feed x people. Because x is still x. X represents the number of people. So we know that it's 20 pizzas, and those will feed x people. So Derek works at Subway. He's making his money. He makes $9.25 an hour. The function d of x equals 9.25x tells us how much money Derek makes after x hours of working. What does d of 4 equal 37 mean? So 4 is the input. 4 is in place of x, and the function tells us how much money he makes after working x hours. So this tells us that Derek makes $37 after working 4 hours. And so that's interpreting function notation. So in this module, we covered a few things. We covered function notation. We covered linear, exponential, and quadratic, and differentiating between them. We also covered simplifying algebraic expressions. So this has been a quick review of the Module 1 material that we went over this year. And good luck as you're assessed on this information. I'm sure as you study and review this video, you're going to do well. Way to go, Wildcats.